open books. You're going to need to label a new tab. Okay, we are still factoring trinomials. So the next tab, we're going to write it down as factoring trinomials, but it looks a little bit different. It's going to look like ax squared plus bx plus c. So write this into your book, please. When we do our examples today, I want you to write them in this tab. So that you'll lift up the top pages and you'll write them in here where it says factoring trinomials. Okay. So let's go ahead and go through some examples. Now, we are getting to the point where you're going to have to start making some decisions. This example that I've got, oops, it's kind of hard to tell, isn't it? I need to know, is this in the form of x squared plus bx plus c, or is it a x squared plus bx plus c? X squared. Does everybody see that? X squared plus bx plus c. Okay. If it was ax squared, we'd have something else in front of this x squared, wouldn't we? Okay. So this is a problem just like we've been doing. We would be able to factor it like normal. Let's do this one real quick just as a review. What would we put in the top left-hand corner? Evan? What would we put in the top left-hand corner? Aubrey, you turn around, please. What are we going to put in the top left-hand corner of our box? Thank you. X squared. What are we going to put in the bottom right-hand corner, Kelby? 20. So we're looking for two numbers that multiply to what? 20. And those same two numbers that add to positive 9. What are those numbers?
5 and 4.
5 and 4. You guys are already getting so much better at this factoring. Yesterday, when I was grading the book assignment, like the page 833, those of you that went back and corrected your first assignment and then went to the 833, you guys were kicking butt on this. You were doing really good. And I really think factoring is one of the things that once you get it, you're going to get it. We just got to keep practicing and keep going with it. Because the hardest part, in my opinion, is coming up with these factors. And the more you do it, you'll start to see that you're probably going to use the same factors over and over again, typically. Let's go ahead and put this into our table, or our box. We have 5x and we have 4x. And then let's factor. In our first column, what's our greatest common factor? X. In the second column? 4. What about the first row? Second row? 5. So our factored form would be x plus 4, x plus 5. Now remember, we could have flip-flopped this, of course, and said x plus 5, x plus 4. Do we need to solve in this problem? How do we know when to solve? With an equal sign, or maybe it'll tell you to solve. Okay, so this problem is just this. Look at this example. 7x squared plus 29x plus 4. Now, is this, you've got to make a decision. It's a trinomial. There's 3 terms, correct? So we need to decide, is this in the form of x squared plus bx plus c, or is it ax squared plus bx plus c? Ax squared. Okay, and again, that looks like this. Ax squared plus bx plus c. It's got that number in front of x squared, doesn't it? Okay. We're going to initially set up our box the exact same way. We're still going to have 7x squared in the top. We're going to have 4 in the bottom right. Nothing's changed, has it? Okay. What is going to be different is what we are trying to get these two numbers to multiply to. They're still going to add to that middle number, 29. They're still going to add to 29. But they are going to multiply to 28. Where did I get 28? 7 times 4. 7 times 4. See where I got the 7 and 4? Okay. I'm going to take that quadratic 7, multiply by that constant 4. 7 times 4 is 28. So we want them to now multiply to 28. But when we add them, we want them to add to 29. What are those factors?
28 and 1.
28 and 1. Well, let's use those two factors. Put them in your box just like we did before. So we have 28x and we have 1x. And now factor. And now factor. In your first column, what is the greatest common factor? 7x. There's a 7 and an x. Doesn't 7 go into 7? And 7 go into 28? And of course they both have an x that you can take out, so we would say 7x. In the second column, what is your greatest common factor? 1, not x. Why can't I take an x out of that first column? There's not an x with the 4. Go to your first row. What is your greatest common factor here? 1x or just x. Thank you. In the second row, what is your greatest common factor? 4. So how are we going to write our answer?
7x plus 1.
And times x plus 4. And like before, we could have flip-flopped those, and we could have said x plus 4. 7x plus 1. How different is today than what we've done previously? One measly number, isn't it? Right here, this 28. Where that came from. Does everybody remember where I got that 28? 7 times 4. I just multiplied to get that. But the process is still the same. We're still setting up our box. We'll do greatest common factor. Everything else is the same. Let's do some more where we have that a term up there that we've got to deal with. So example 3. And again, keep putting these examples into your book. The more you have, the better off you're going to be. Okay, in example number 3, you need to make a decision. Is this in the form of ax squared plus bx plus c, or is it x squared plus bx plus c? Ax squared. And again, how do we know that?
The 3 in front of the x.
The 3 in front of the x. So set up your box. Everything starts exactly the same way. 3x squared to go in the top left. 20 is going to go in the bottom right. That doesn't change. What part of this changes? What they multiply to. It's not going to multiply to 20 anymore. What's it going to multiply to? 60. And how did we get 60? 3 times 20. 3 times 20 gave us the 60. Okay, so we got that. We still wanted to add to negative 17, don't we? So what are the factors of 60? Two numbers that multiply to 60 and add to negative 17. Okay, if we use negative 20 times 3, does that multiply to a positive 60? Multiply to a negative 60. You're close. What else could we use? What is it? Okay, we have to use two negatives, it looks like. How do you go about it if you don't know? I mean, sometimes you come up with the factors pretty easily, but what if we can't come up with them? What's the best way to do this? What did I tell you the other day? Okay, so just come up with your factors and that. I said, let's just list them. Let's do that right here in this example. So we know 1 and 60. Those are the easy ones. I'm just going to kind of go in order here. 2 and 30. Now thinking they're going to have to multiply to a positive 60. So they're both going to have to be positive or both going to have to be negative. And then when I add those numbers, I want to be able to get 17. Or negative 17 if they're both negative. Can I add these two or these two and get 17 out of them? No. Let's do 3 and 10. Can I get 17 or negative 17 out of 3 and 10? No. Does 4 go in? Take 60 divided by 4 in your calculator. Do this with me, guys.
15.
Yes, 4 and 15. Can I get negative 17 or 17 out of 4 and 15 if I add those? No. What about 5? 5 and 12? Okay, if I add 5 and 12, can I get 17 or negative 17 out of that? Yes. What does it need to be? Positive 5 and positive 12 or negative 5 and negative 12? Negative 5 times negative 12. Because a negative times a negative is a positive. So let's use negative 5 and negative 12 in our box. And now factor. In your first column, what is your greatest common factor? Not 3x. X. What about your second column? Negative 4. 4 goes into 20. Wow, why did we use a negative 4 as opposed to a positive 4? Good. The first number in our column is a negative, so we will factor out a negative. In this first row, what's your greatest common factor? 3x. What about the second row?
A negative 5.
Negative 5. Go ahead and write our answer. We have x minus 4 and 3x minus 5. Michael?
Can you switch the 5 and the 12 around?
Good question. Could we flip-flop these two? Absolutely. And it will be fine. You should get the same factors. Just what I have on top is what you're going to have on the side. What I have on the side is what you have on the top. Put this next one in your notes for sure. And I want you to have one of these examples in your book. So number 4. (4x squared minus 3x plus 5). Is this in the form of x squared plus bx plus c, or is it ax squared plus bx plus c?
Ax squared.
Good. It is, of course, ax squared plus bx plus c. Okay, so set up our box. We have 4x squared and 5. What do we want these factors to multiply to? 20. How did we get 20? 4 times 5. We wanted to add or multiply to 4 times 5, 20. And then we wanted to add to what? Add to negative 3. Can you think of factors of 20 that add to negative 3? Well, let's list them. Let's list them. We have 1 and 20. 1 times 20. We have 2 and 10. 3 doesn't go in, so we skip that number. 4 goes in, though. 4 and 5. And then we're up to 5. Well, that would be 5 and 4, wouldn't it? We've already listed. Can I get negative 3 out of any of these? So what do we do? What if there aren't any factors? We're not solving. It wouldn't be no solution. There's actually a new name. Have you heard of prime before? Something is not factorable when we say it's prime. For example, the number 17 is considered a prime number, isn't it? It doesn't have any factors other than 1 and 17. Okay, so we would call that a prime number. So when something is not factorable, we would say it's prime. Like the number 10, would that be considered a prime number? No, because we can factor it 5 and 2. Alright. So we are really just continuing on with what we've been doing the last couple of days with this box method. We've just added that little a in the front, and that just affects what we're multiplying to. I am going to stop here so you guys can get started on your homework and hopefully finish it and have no homework for the weekend. Your assignment is on page 496. Numbers 1 through 8. 10 to 28 evens. Yes, ma'am. 30. 55 through 60. Now, I think there are some moving problems in here. We can omit number 20. I will allow you to work with a partner today as long as you are on task and working.
Negative.